determine whether the vectors, these four vectors 1 0 minus 1 2 0 minus 1 minus 1 0 0 minus 8 minus 12 minus 4 3 6 3 minus 6 belongs to m2 by 2r. These are the vectors of m2 by 2r. M2 by 2r is what? This is the m2 by 2 right in bracket r. So this is what is the vector space of all 2 by 2 matrices with real entries. So m2 by 2 in round bracket r are independent or is dependent, independent or dependent. Well, determine whether these four vectors are linear dependent or independent. So first we denote these vectors as capital A, capital B, capital C, and capital D, or directly write. There are four vectors. We have to determine these four vectors are linearly dependent or independent. So we take four scalars. So first sentence is what? Let K1, K2, K3 be scalars such that K1 into the first vector A plus K2 into the second B plus K3 into C plus K4 into D is equal to 0 bar. So what is 0 bar? This is not 3 tuple 0 bar. 0 bar, write 0 bar as a 0 vector of this m2 by 2r, and it is a 2 by 2 matrix. It is 0 0 0 0 2 by 2 matrix of, with all entries are 0. So this is 0 bar of this m2 by 2r. So write first sentence that let K1, K2, K3 be K1, K2, K3, K4, because there are four vectors. So let first sentence is what? Let K1, K2, K3, K4 be scalars such that K1 into A plus K2 into B plus K3 into C plus K4 into D is equal to 0 bar, and then write K1 value of A as 1 0 minus 1 2, B value of B, value of C, value of D, and then write here the 0 bar as this vector 0 0 0 0 matrix 0 0 0. Then apply the definition of scalar multiplication first, that is multiply by K1 to each element. So we have K1 0 minus K1 2 K1. Then also apply the definition of scalar multiplication on this. So we have 0 minus K2 minus K2 0, then 0 minus 8 K3 minus 12 K3 minus 4 K3. Similarly 3 K4, 6 K4, 3 K4 minus 6 K4 is equal to 0 0 0. And then add the these four matrices. So we have K1 plus 3 K4, then minus K2 minus K2 minus 8 K3 and plus 6 K4, and then similarly minus we have the element minus K1 minus K2 minus 12 K3 plus 3 K4, and then 2 K1 minus 4 K3 minus 6 K4 is equal to 0 0 0 0. Okay, so after comparing LHS and RHS, we have K1 plus 3 K4 is equal to 0, then minus K2 minus 8 K3 plus 6 K4 is equal to 0, and then minus K1 minus K2 minus 12 K3 plus 3 K4 is equal to 0, and similarly this 2 K1 minus 4 K3 plus minus 6 K4 is equal to 0. So we have this. So after comparing LHS and RHS, we have the these four equations. So we have the four equations, and there are four unknowns. So we have to solve this system. We have to solve this system, and we have to find the values of K1, K2, K3, K4. So in order to solve this system, form the augmented matrix. So in order to solve any system, either it is homogeneous, non-homogeneous, number of equations and number of unknowns are same or different, in all cases we have to use the Gauss elimination method. That is just form the augmented matrix, reduce the matrix to echelon form, and write the rank of A and rank of AB, both are equal, then system is consistent, both are not equal, then system is inconsistent, and then if the system is consistent, then rewrite the equation. We have the values of K1, K2, K3, K4, or values of unknowns. So this is the simple Gauss elimination method. And in order to solve any system, either it is homogeneous, this is a homogeneous system because all are equal to 0. But if the system is non-homogeneous, then also use Gauss elimination method. So form the augmented matrix. So the coefficient of K1, K2, K3, K4 and is equal to 0. Then coefficient of K1 is 0, K2 is -1, K3 is -8, 6, 0. Then coefficient of K1, K2, K3, K4, and the last row. And then we have to reduce this matrix to echelon form. So we have to reduce this element to 1. It is already 1. So we have to reduce the all below element are equal to 0. This is 0. So we have to reduce this -1 and 2 to 0. So application are transformation are R3 plus R1 and R4 minus 2 R1. So we have the first two rows as it is here 0, and then after calculation we have this. These are the rows. Okay. Now we have to reduce this element -1 to 1. So just multiply second row by -1. So -1 into R2 or minus R2. So change the sign of second row, remaining row as it is. Now we have to reduce this two element to 0. Already this is 0. So I have to reduce this -1 to 0. So it is in the third row. So R3 plus R2. So by using this one, we have to reduce this two element to 0. So we have this. And then we have to reduce this -4 to 1. So -1 by 4 R3. What is the application? -1 by 4 R3 or minus R3 by 4. So we have the change in the only third row. We have this third row. And then we have to reduce this -4 to 0. So for that, we apply the application. We have to reduce this -4 to 0. So the application is what? R4 plus 4 R3. And so we have this is the matrix R4. So here we have 0 and this -12 as it is. And then last application is -1 by 12 R4. After this application, apply the application -1 by 4 -1 by 12 R4. We have this matrix. And this is the matrix in echelon form. So this is the homogeneous system. So there is no question of inconsistency, because the homogeneous system are always consistent. Every homogeneous system is consistent, and so there is no question that rank of A and rank of rank of AB are different in the homogeneous case. Or if we write the rank of A, it is this after cancelling the last column, the remaining matrix is the echelon form of the matrix A, and if you observe, all these four rows are non-zero. So rank of A is 4, and this whole matrix is the echelon form of the matrix AB, and it also contains all rows are non-zero, and therefore rank of A and rank of AB both are 4, and is equal to number of unknowns. So this system has unique solution, because we have that rank of A is equal to rank of AB is equal to number of unknowns. Number of unknowns are 4, K1, K2, K3, K4, and so the system has unique solution. So we have to rewrite the equation. So K1 plus 3K2 K4 is equal to 0 is the first equation. Then second equation, K2 plus 8K3 minus 6K4 is equal to 0 is the second equation. Third equation, K3 is equal to 0, and the last equation, K4 is equal to 0. So K4 and K3, if you substitute in the above equation, we have K1 and K2 both are 0. And we know that if the system, homogeneous system, has unique solution, then it must be a 0 solution. That is, all the values of unknowns are equal to 0. So we have the K1 is 0, K2 is 0, K3 is 0, K4 is 0. And all constants K1, K2, K3, K4 are 0. And therefore the given vectors V1, V2, V3, V4 are, suppose these vectors are capital A, capital B, and capital C, and capital D. So say that capital A, capital B, capital C, capital D are linearly independent. So when the vectors are linearly dependent, if out of these scalars K1, K2, K3, K4, one of them is not equal to 0, but all are equal to 0, and therefore the given 4 vectors are linearly independent. Next problem, for which vectors of lambda do the following vectors, these V1, V2, V3 are dependent in R3? For which values? So right here values, for which values of lambda do the following vectors V1, V2, V3, V4, these vectors are linearly dependent in R3. So for which value of lambda these 3 vectors are linearly dependent? So we denote these 3 vectors by V1, V2, V3. There the notation is given in the problem. So let K1, K2, K3 be scalar such that K1 V1 plus K2 V2 plus K3 V3 is equal to 0 bar. So write that sentence first. Let K1, K2, K3 be scalar such that K1 V1 plus K2 V2 plus K3 V3 is equal to 0 bar. And then write the values of V1, V2, V3 and 0 bar as 0, 0, 0 till tuple. And then apply the definition of scalar multiplication and vector addition. That is multiply by K1 to each element and K2 to each element, K3 to each component. Okay, X, Y, Z. And then add the corresponding vectors, corresponding components. That is apply the definition of scalar multiplication and addition in R3. And after comparing LHS and RHS, we have this system that lambda K1, then minus 1 half K2, and minus 1 by 1 half K3 is equal to 0. The next is minus 1 half K1, lambda K2, and minus 1 half K3 is equal to 0. So then last equation minus 1 half K1, minus 1 half K2 plus lambda K3 is equal to 0. So write that in between steps. That is, first write the sentence let K1, K2, K3 be scalar such that K1 V1 plus K2 V2 plus K3 V3 is equal to 0 bar. And then substitute the values these. And then apply the definition of scalar multiplication, write one more step, and then write one more step that add the elements, and then compare. We have this system. Now we have to solve this system, and we have to find the values of K1, K2, K3. So augmented matrix is this. So coefficient of K1, K2, K3 is equal to 0. Now we have to reduce this matrix to echelon form. We have to reduce the matrix to echelon form. So in order to reduce the matrix to echelon form, this is the matrix. We interchange the first and third row. First and third row. So we have this as the first and third row after interchanging. Then we have to reduce this minus 1 half to 1. So we multiply by minus 2 to R1. Minus 2 R1. So write the apply the step minus 1 minus 1 minus 2 R minus 2 into R1. Similarly, multiply minus 2 to R2 and minus 2 to R3 in order to cancel the fractions. In order to cancel the fractions, or we can remain these fractions as it is. So we are, in order to cancel the fractions, we multiply to second row, first row by minus 2, second row by minus 2, and third row also by minus 2. So we have this matrix after multiplying this, after these three transformation. Then we have to reduce these two element to 0. So for that, to reduce this 1 to 0, so application is R2 minus R1, and to reduce this minus 2 alpha to 0, the application is this R3 plus 2 lambda R1. So first row as it is, second change is this, and the third is this 0. Then my 2 alpha plus 1 is 1 plus 2 alpha. Then 2 alpha into minus 2 alpha becomes minus 4 alpha square. So 1 minus 4 alpha square, 0. So after this application, we have this matrix. Then we have to reduce this matrix to again echelon form. In order to that, we have to reduce this element to 1. So when we reduce this element to 1, if this is not equal to 0, minus 2 alpha minus 2 lambda minus 1 is not equal to 0, that is 2 lambda plus 1 is not equal to 0. So I assume that 1 plus 2 lambda is not equal to 0, or we assume that minus 2 lambda minus 1 is not equal to 0. This element is not equal to 0. Obviously, we have this 1 plus 2 lambda is not equal to 0. Then minus 1 by 1 plus 2 lambda application. In order to reduce this element to 1, we divided by the same. That is minus 1 by minus 2 alpha minus 1. 1 by minus 2 lambda minus 1. Or write minus 1 by 1 plus 2 lambda. So we have the element 1. Here we have minus 1 because here we have 0. Then the first and third row as it is. Then we have to reduce this 1 plus 2 alpha to 0. So R3 minus in bracket 1 plus 2 alpha R2. This is the application. R3 minus 1 plus 2 alpha R2. So first row as it is, second row as it is, the third row is here we have 0. And after calculation, that is 1 plus 2 alpha into minus 1 is minus 1 minus 2 alpha plus this. So we have minus 4 lambda square plus 2 lambda minus 2 minus 1 minus 1 minus 2 is equal to 0. not minus 1, plus 2, plus 2, plus 2. 1 plus 1 becomes plus 1. So we, after this application, we have this 4 lambda square minus 4 lambda square plus 2 lambda plus 2. And now we have to reduce this again to echelon form. Then we have to reduce this element to 1. But when this reduced to 1, if it is not equal to 0, but the given vectors are linearly dependent. If so, when the vectors are, these three vectors are linearly dependent, if this system has a non-trivial solution, or if these K1, K2, K3 are not all equal to 0. So this is the homogeneous system. And this homogeneous system has non-trivial solution. When this homogeneous system has non-trivial solution, if the rank of A is equal to rank of AB is strictly less than the number of unknowns, and the number of unknowns are 3. So when this system has non-trivial solution, non-zero solution, if the rank of A and rank of AB, these two are equal and is strictly less than number of unknowns, means 3. Means when this matrix has, this system has non-trivial solution, that is non-trivial solution means K1, K2, K3 are not all equal to 0. When this happens, if the rank of A or rank of AB is strictly less than number of unknowns, means number 3, that is if the rank of A and rank of AB is equal to 2 or 1. So when the matrix from this, we observe that the rank of A is equal to 3 if this quantity is not equal to 0. And but if this quantity is equal to 0, then rank of A becomes 2, and it is strictly less than number of unknowns, that is 3. So in order, and in that case, the system has non-trivial solution, means the system has, means these K1, K2, K3 are not all 0. So when the K1, K2, K3 are not all 0, if this is equal to 0, and if the K1, K2, K3 are not all equal to 0, then the given vectors are linearly dependent. And therefore, the sentence is the given vectors V1, V2, V3 are linearly dependent if. So we are given that we have to find the value of lambda under which these three vectors are linearly dependent in R3. So the vectors V1, V2, V3 are linearly dependent if this is equal to 0, minus 4 lambda square plus 2 lambda plus 2 is equal to 0. And when we, after solving this equation, what we have, dividing by 2 and then factorize, we have the roots are lambda minus 1. These are the factorization. Minus 2 lambda minus 1 is equal to 0. And that is the factorization is what? 2 minus 2 lambda minus 1. Minus 1 lambda, because 2 lambda minus 1 lambda is lambda, and the multiplication is minus 2. So we have, after simplification, lambda is 1 and lambda is minus half. So these are the values of lambda. If we take lambda as 1 or lambda as minus 1 half, then these three vectors are V1, V2, V3 are linearly dependent in R3. So the vectors are linearly dependent. V1, V2, V3 are linearly dependent if lambda is either 1 or lambda is minus half. So similarly, we will solve the remaining examples in the next lecture.